All right, I'm going to set these up. And just remember that these probabilities is going to be one out of whatever this number is. So I don't want, and then there would be percentages. What I want to focus on is just getting these calculations correct, these setups correct, because you can just punch in the calculator. Okay. Okay. Now, this is pretty basic because this is, we've got all these ingredients here, 6, and then this is 8. We got a total of 14 ingredients, right? So with 14 ingredients, what is the probability of you actually getting those ingredient, like how many different combinations can you have just having one topping? Okay. Now, if there's 14 ingredients, it's going to be 14 and you're choosing one. How many ways can you choose one? 14 times. Okay. So if you know how to set it up, all right, if you do enough of these, you'll know that there's only one combination that you can choose one out of 14. In fact, you can, I don't know if you guys picked up on this either, but there's only one way that you can choose 14 objects out of 14 in order not matter, okay? So I want you to know that these guys kind of work together, all right? In fact, you can kind of, I do believe that, something like this, like those guys equal the same number. It's like, it's just the kind of the symmetry of the situation, okay? All right, so this would be 1 out of 14, all right? And I do believe that's 7.1%. All right, now you're going to choose any three toppings. Okay, well, any three toppings would be, you've got 14 of them, so just choose 3. All right, I don't know how much that is. My guess is that it's 364. Okay, so what percentage is that? 1 out of 364 is 0.27%. Pretty small. How about meat beast? Choose any 4 meats. Okay, so choose any 4 meats. How many different ways can you do that? Well, how many different meats are there? There's 6, right? Okay, so 6 choose 4. 6 choose 4, I believe, is 15. Okay, I'm going to verify that just for a second. Okay, so go to the math button, push over to probability. We're going to go here. All right, and remember, this is because order does not count. Okay, order does not count. There it is, 15. So that's 1 out of 15, and that would be 6.7%. Okay. Veganator, choose any 5 vegetables or fruit. So 5, you've got 8 different vegetables. You're going to choose 6 of them. How many different ways can you do that? Well, it's actually 56. Okay. So these, believe it or not, all of these numbers here are actually in the Pascal's triangle, by the way. I feel like I should make a video of that someday, but it's pretty outstanding how all of these combination numbers are actually in Pascal's triangle. But yeah, I won't do that. Okay. 1 out of 56 is pretty small. Okay, what is that? Veganator. That's 1.8%. All right, so the dozen, choose any 12 toppings. So it looks like we're going back to all 14 of them. Okay. That's 91 different ways. So 1 out of 91 is pretty small. Okay, small percentage. All right, so now we got to choose 2 meats and 2 veggies. Now here's where it gets pretty interesting, but it's actually, experience will just kind of like allow you to kind of figure this out. If you're going to have 2 meats being chosen out of 6, okay, then you're going to multiply by all of the other combinations that you would get choosing 2 veggies, okay? And there's 8 of those. So here's the meat combo, here's the veggie combo. Put those 2 together, and that would be a multiplication situation. So that actually equals 420, okay? And 1 over 420 is, wait, did I do that wrong there? Oh, you know what? This is 0.24, and this guy is 1.1%. Okay. Okay, so these are very low probabilities for them to guess the pizza. Okay, extremely, extremely. All right, so balanced meat then, choose 4 meats multiplied to choosing 4 veggies. Okay, so that is 1,050. So there's no way that they're going to guess the right combination for that. That is 0.095%. So talking less than 100th of a percent. Okay. All right. So I'm going to just ignore those questions for now. This is what I want you to focus on for the test. Okay. And then we'll get to the back here. A young salesman is planning her next. Let's see. A young saleswoman is planning her next business trip. She packs 2 pairs of shoes. 4 skirts, 6 blouses, and 2 jackets. So how many possible outfits? This is just the fundamental counting principle here. So you can see that you just get, 8 times 12? What is that? 8 times 12 is going to be 96. Okay, so 96 different ways. Florida license plate. I do believe we kind of did this because I thought that's how Michigan was, right? It's followed by 3 numbers. Yeah, we already calculated that. So it should be 26 times 26 times 26 times the 3 possibilities that you can have for the numbers. So that is quite a bit, 17 million. Actually, I think this is pretty close to the population of Florida. Knowing the conditions for Florida license plate, how many different ways can you start with Z and then end with 9? Okay, well, how many different plates? Okay, well, what they did is they took your choices away for the first slot and the last slot. You can only have one condition for the first slot. So everything else is up and available, okay? But they took away the choices here for Z and for the 9. So there's only one way that you can have the 9 and only one way for the Z. So how many different plates have that? Well, what is 26 squared? 26 squared times 10 squared, which is 100, is 67,600. Okay. All right. Next, the student council is made up of 15 males and 20 females. How many different 4-member committees? Okay. Now here we can definitely see that they have assigned roles for each of these 4 roles: president, vice president, secretary, treasurer. So out of 35 people, okay, I'm going to choose 4 roles, but it's going to be a P because the order matters. If one person in the group is president and the other is vice president, that's going to be a different situation than if the roles were switched, okay? So this is a permutation, and that is the difference. I mean, again, order is a huge deal in probability, okay? So whatever that is, it's going to be a lot. I do believe it is 1,256,640, okay? But then when you get to number 5, this is a tough one. This is a really hard one. This guy here, this I'm not going to test you on because it's probably a little above our pay grade here. But if you had to have 2 female, or at least 2 females, what you have to do is think of all the possibilities then, okay, where if you had all 4, okay, were female, and okay, you've got okay, you've got how many? 20? Okay, so you got 20 females, and you're going to choose all 4, okay? Then you don't need any males for that guy, okay? But now you're going to add, okay, so this is if all 4 females were chosen. If you're going to add the situation where you had out of 20, you're going to grab 3 females, then you need to multiply by the fact that you need at least 1 male, okay? So notice that this is the second possible situation, okay? Here's the third possibility, where what if you only chose 2, okay? So here is where 2 of them get multiplied to you having to have 2 males. So you can see that that is kind of sophisticated. I'm actually glad this problem, you guys saw this, because here's where probability gets really, really tricky. And this is a whole new level of like thinking about problems. And these are the kind of problems that I had trouble with when I was in college. So if you can wrap your head around this, probability and statistics might be the kind of thing for you. But don't worry, I'm not going to put this on the test. But this is just for 4 females, 3 females, and 2 females. You have to account for how many ways the males kind of squeeze into the situation as well. Okay, so tough one. I do believe the answer to this guy, though, is 4. I don't even think it's the correct answer. They're saying that it's 401, 280, but that is not actually correct. So, and I triple check this. Anyways, Ice Cream Shop offers a selection of 25 flavors. Jasmine orders a 3-scoop cone with different flavors, and she is picky about the order. Okay. So now they're saying that the order does count, and she's going to have 25 possible flavors. She's going to choose 3. That's probably a large number. It's hard to believe that there'd be 13,800 different ways of arranging 3 scoops of ice cream, but there are 25 flavors, so that's what pushes that quite large. Pizza Parlor offers 6 different toppings. This is very similar to the back. How many ways? 2-topping pizza. Okay, so if you oh, that's a good question here. Okay, does it matter? There's 6 different toppings, and you're going to choose 2, right? Okay. Now, what I'm curious, though, 6 choose 2, I believe, is... I'm curious, what if you could add... What if it was extra? Like extra pepperoni, okay? So what if you just said pepperoni, pepperoni? So then how many possibilities do you have now? You have 12, right? So, yeah, pretty interesting. But let's just say that you can't, okay? They're looking for the answer 15, okay? Teacher creates a 10-question quiz with 5 multiple-choice questions and 5 true or false questions. Okay, so this guy right here, it looks like we're going to add the probability of them getting the 10 questions correct in a row. Okay, I'm sorry, the first 5 is multiple choice. There are 5 possibilities for each one, right? 4 possible. So 4 times 4 times 4 times 4 times 4. Those are 1 out of that many for you to get all 5 correct. Okay, so 4 to the 5th power is quite large. Okay, it's 1,024. 1 out of 1,024. Now, what about the other ones? There's 5 true false. Well, there are 5 possibilities for that. Okay, and 2 to the 5th power is 32. So that's for the multiple choice part. And then this is, multiple choice part, true or false part. So what happens then when you've got both of them? In order to have both of them, you're going to actually have to multiply those guys. So that is a lot. So to guess your way on a 10 question, half multiple choice, half true and false, you'd think that it would be better than 1 out of that, but it's not. There's a lot of possibilities there. Okay. All right. Now, this guy is Jacob orders 3 scoops of ice cream, and unlike Janet, there's no order to the desert. So how many can he get? So that is an easy one. That all of a sudden just changed to a combo. All right, so let's see how many ways you can choose that, and you probably know already through the process of elimination. If you got 24, we're going to choose 3, and that is 2024. 2024. Let's see. Jacob orders 3 scoops of ice cream, and unlike Jasmine, there is no order to his desert. How many 3-scoop bowls are possible? Oh, that's oh my gosh! I chose 24 instead of 25. My bad. Let's make that 25. There it is. 2000. 300. I didn't see 2024 in the answer there. So, just adding one extra flavor, just increased it by 76 possibilities. So, pretty neat. Pretty neat. All right, is that everything? That is everything, ladies and gentlemen. Good luck on the final.